Your app runs perfectly on your laptop, then you deploy it to the server and everything breaks because of a missing library or a different node version. This is the classic dependency problem that has haunted developers for decades. Docker solves it by packaging your application together with its entire runtime environment, the exact node version, the exact system libraries, everything. GitHub Actions takes it one step further by building the Docker image automatically on every single commit. The result is a repeatable, auditable artifact that behaves identically on your laptop, in CI, in staging, and in production. GitHub Container Registry, GHCR.io, is a fully Docker-compatible image registry that lives right inside your GitHub account. You do not need Docker Hub, AWS ECR, or any external service. 4 public repositories, storage, and bandwidth are completely free. For private packages, usage counts against your GitHub plan quota. The most powerful feature is authentication. GitHub Actions can push images using the built-in GitHub_token, which means 0 additional secrets to configure. Your container images live right next to the code that produces them, making the relationship between source and artifact completely traceable. A multi-stage Dockerfile uses 2 or more from statements in a single file, each representing a distinct build stage. The first stage, often called the builder, uses a full-featured base image to compile code, run tests, and produce build artifacts. The second stage, the production image, starts from a slim base like Alpine and copies only the compile output from the builder. Build tools, compilers, and development dependencies never make it into the final image. The result is typically 80% smaller than a naive single-stage build, with a dramatically reduced attack surface and significantly faster container startup and pull times. The Dockerfile begins with Node 20 as the builder stage. This full image has everything needed to compile TypeScript and install all dependencies. We copy package.json first, run npm CI to install dependencies, then copy the source code and run the build. The second stage starts completely fresh from Node 20 Alpine, a minimal Linux space around 180 megabytes. We use copy with the from flag to pull only the compiled dist folder and the runtime node_modules from the builder stage. Nothing else comes along for the ride. The final image exposes port 3000 and runs the compiled JavaScript directly. The pipeline has 4 sequential steps, each handled by a dedicated GitHub action maintained by the Docker team. Step 1 checks out your code with action/checkout. Step 2 authenticates to GHCR.io using Docker/login action with the built-in token, no secrets to manage. Step 3 runs Docker/metadata-action, which inspects the Git ref and automatically generates the correct image tags for this event. Step 4 is the build and push itself, handled by Docker/build_push-action, which builds the Dockerfile using BuildKit and pushes the resulting image to GHCR.io with all the tags generated in the previous step. The Docker/login action at version 3 handles authentication to any Docker-compatible registry. We set the registry to GHCR.io, the username to GitHub.actor, which resolves to the user or bot that triggered the workflow, and the password to secrets.github_token. That token is automatically injected by the action's runtime. You do not create or store it anywhere. The only configuration you need is to declare the package's write permission in your workflow's permissions block, which grants the token the right to push images to the registry. This is the principle of least privilege applied to CI authentication. The Docker/metadata-action at version 5 is a tag generation engine that understands Git semantics. We give it the base image name, GHCR.io, followed by the repository path and a list of tag types. The type equals SHA entry produces a tag like SHA-A1B2C3D, derived from the short commit hash. The type equals raw entry with value latest and an enable condition produces the latest tag only when pushing to the main branch. The type equals semver entry automatically produces version tags like 1.2.3 and 1.2 when you push a git tag. The action outputs a structured list of tags that the build step consumes directly, keeping your workflow dry. The Docker/build_push action at version 5 is the workhorse of the pipeline. We set context to a dot to use the repository root as the Docker build context. The push flag is set to true, without it the action performs a local build only. The tags field references the outputs from the metadata step, consuming every tag that was generated. The cache from and cache to fields both use type equals GA, which stores Docker layer cache in the GitHub Actions cache service. This is the single biggest lever for build speed. A warm cache can reduce a 3-minute build to under 30 seconds on subsequent runs. Here is the full workflow wired together. It triggers on pushes to the main branch. The permissions block declares contents read for checkout and packages write to enable pushing to GHCR.io. Without that second permission, the push step returns a 403. The steps run in order: checkout, login, metadata generation with the step ID of meta, and finally build and push. The build step references the metadata outputs by using the step ID in the tags field. The cache configuration is included on both the from and to side, so each run reads from and writes back to the layer cache. This entire workflow is fewer than 40 lines and handles everything automatically. The latest tag is a lie. It is a mutable pointer that changes silently with every push to main, and once overwritten you have no way to know what code it contains. In production environments this is unacceptable. You need to know exactly which build is running at all times. The commit SHA tag solves this. SHA1B2C3D is immutable by definition, because the SHA is derived from the content of the commit itself. Use latest for developer convenience, pulling the most recent version locally or spinning up a demo environment. Use the SHA tag for anything that matters: staging, production, Kubernetes deployments, and incident rollbacks. Semver tags serve external consumers and release automation. Docker layer caching works by invalidating a layer and all subsequent layers the moment any input file changes. If you copy the entire source tree before running npm CI, then every single code change, even a one-line comment edit, forces a full npm install on the next build. The fix is simple: copy package.json and packagelock.json first, run npm CI, and only then copy the rest of the source. Now npm CI is cached in its own layer that only invalidates when your actual dependencies change. Paired with the GitHub Actions cache backend using type equals ga and mode equals max, which persists all layers including intermediate stages, you get near-instant rebuilds for the vast majority of commits. The platform's field in build push action accepts a comma-separated list of target architectures. Setting it to Linux/AMD64, Linux/ARM64 produces a multi-platform OCI image index, a single tag that contains separate image manifests for each architecture. When a developer on an Apple Silicon Mac runs Docker pull, Docker automatically selects the ARM64 manifest. When a Kubernetes node on an AMD64 cloud server pulls the same tag, it gets the AMD64 manifest. You must add Docker/setup builds action before the build step to enable BuildKit's cross-platform builder. AWS Graviton and Azure Ampere instances are ARM64 and can be 20 to 40% cheaper. Multi-platform builds unlock that savings with zero change to your deployment workflow. The deploy job declares a dependency on the build job using the needs keyword, ensuring it only runs after the image has been successfully pushed to GHCR.io. The build job exports the exact image tag through its outputs field, and the deploy job reads that value through the needs context. The deployment command pulls the image using the SHA tag, not latest, then stops the running container and starts a fresh one with the pinned image. This guarantees that even if another push happened between the build and deploy steps, you are still deploying the exact image that was built in this workflow run. This pattern is the foundation of reproducible, auditable continuous delivery. Let's verify your understanding of image tagging before moving on. Think carefully about what happens when you push to main multiple times in quick succession. Consider what latest actually points to and how that changes over time. The answer has nothing to do with technical limitations of Docker or GHCR. It is entirely about operational safety and the ability to reproduce and roll back a specific deployment. The SHA tag gives you a permanent, immutable handle on exactly which code, which dependencies, and which build produced the image you are running in production. That traceability is what separates professional deployments from fragile ones.